Now see in this example, a house uses an electric heater of 1 kilowatt for 2 hours daily and 2 bulbs of 60 watt for 6 hours daily. How much total energy is consumed in a month of 30 days, and what is total electric bill if cost of 1 unit is rupees 3? So now see, we have to calculate total energy consumed in a month and then bill. So we know it, energy is equal to power into time. So first we calculate energy consumed by electric heater in 1 day. So we can write E1 is equal to, power is given to you 1 kilowatt, so 1 kilowatt into 2 hours, that is 2 kilowatt hour. Then we can calculate this, I am writing here energy consumed in 1 day. Then we can write energy consumed by bulb. There are 2 bulbs of 60 watt, 2 into 60 watt we can convert into kilowatt, because we have to calculate energy in commercial unit. So this 60 watt can be written here 60 divided by 1000 kilowatt multiplied by 6 hours daily, so that is 6 hour. So now we can write here 2 into 0.06 into 6 kilowatt hour, that is 0.72 kilowatt hour. This is total energy consumed by bulbs in 1 day. Total energy in 30 days, total energy in 30 days, that will be E is equal to sum of these two, that is 2.72 into 30 is equal to, we can write here 681.6 kilowatt hour. And now total bill, this is the total unit 81.6 unit, and cost of 1 unit is rupees 3. So total cost we can write 81.6 into 3 rupees, that will be here 3 6 18 4 and 244. So 244.8 rupees. This is the total electric bill. So by this way you can calculate power as energy consumed, and then you can calculate total electric bill for the domestic users. So this is the one example related to electric power and electrical energy. So we can see now the next example. See this example, which has more uses more energy, 300 watt TV set in 1 hour or a 1000 watt toaster in 10 minutes. So see here, there are 2 electrical appliances which are used for different times, having different powers. Now we have to calculate energy. First you can calculate energy for TV set. So we can write here energy consumed by TV set is E is equal to power into time. We can write here ET, that is TV, that shows here the TV set. Power into time, power is 300 watt. So we can use convert into kilowatt. So 300 divided by 1000 kilowatt into 1 hour. We can also do convert 1 hour into seconds, and then we can convert energy in joules. So that is here 0.3 kilowatt hour. Now then we can calculate energy consumed by toaster. So here we can write E toaster is equal to, power is 1000 watt, that means 1 kilowatt hour, 1 kilowatt into time is 10 minutes, that means 10 by 60 hour here. So that is 1 by 6 kilowatt hour. So now see, this is consuming 0.3 kilowatt hour, this is consuming 1 by 6 kilowatt hour, that will be coming 0.16 kilowatt hour. So, obviously energy consumed by TV set is more than the energy consumed by toaster. So, we can write ETV is greater than E toaster. Now, see in the next example here, two lamps, one rated 100 watt at 220 volt and the other 60 watt at 220 volt are connected in parallel. Find current drawn from the supply. So, you have got two bulbs. One bulb is supposed like this, which has got power 100 watt, another has got power of 60 watt. Both are connected in parallel and then both are connected to a supply. So, total supply is also here 220 volt. So, you have to calculate total current drawn. We know here this is I1 and this we can take here I2. Both are connected to the same source. So, we can use power is equal to V into I. So, we can write I is equal to P upon V. First, we can calculate I1 is equal to 100 upon 220. So, this is here 5 and 11, that is 5 by 11 ampere. Similarly, we can calculate I2 60 by 220, 3 by 11, that is here 3 by 11 ampere. Now, you can add these two current to get the total current. I is equal to I1 plus I2, that is 5 by 11 plus 3 by 11 is equal to 8 by 11 ampere. So, you can calculate current by this way. So, these are the certain questions where you have calculated current, energy and power, right, and total electric bill. So, now you try to do all questions given in your book and also look at the assignments. Now, we can take one more example where we have to calculate resistance of bulbs. Suppose now we can take this is example 4. There are two bulbs having different powers. Like one bulb has got power 60 watt and it is rated here 220 volt. Another bulb is power here 100 watt and it is rated also 220 volt. Now, you have to tell which bulb has got greater resistance. So, now see, for calculating resistance in this case, we can use power is equal to V square upon R, or we can write R is equal to V square upon P. So, see, resistance is inversely proportional to P provided V remains constant. So, here V is same for both. When the V is same, resistance is inversely proportional to P. So, see, the bulb which has got a higher power will have got less resistance. So, obviously 2 bulb. So, we can write R2 is less than R1. So, bulb having higher power has the less resistance and the smaller power has more resistance.